Methods of writing chemical formulas. Crisscross methods. Now we have, for example, I'll give the example. Here I want to write aluminium sulfate formula. So I know that aluminium sulfate consists of aluminium and sulfate radical is present in it. Okay, but I don't know whether it is Al2SO3, SO43 or the suffix numbers. I don't know. There only we do mistakes when we write the formulas. Sodium chloride. We know that sodium is there, chlorine is there. But suffix numbers we don't know until unless we can't remember all the molecular formulas. We can't remember all the molecular formulas. Definitely we need to have a trick to write the molecular formulas. Here we are having some tricks like to write the molecular formulas, but to write the molecular formulas with the help of crisscross methods. Crisscross methods. Yes. So I think you have observed the mass number and you have written the electronic configuration. Here nobody works with the mass number. Here we are only dealing with the number of electrons present in the outermost shells. And we are arranging the electrons in different shells based on this electronic configuration. Like 2s per formula up to the lower elements we have taken, and we have observed the drawbacks and we discussed the drawbacks and the arrangement of 2, 8, 8, 18, 18, 32. Understood? Akshay? Everyone? Arjun? Ishan? Kavya? Keertana? Okay, understood?
Yes, ma'am.
Yes, very good. So let us know how to Arya. Yes, Arya. So let us know about how to write the chemical formula by using crisscross methods. Definitely we know that when we hear about the name of the compound, for example, aluminium sulfate is a compound. Definitely in our mind, first of all, we get that compound consists of aluminium and sulfate. Am I right? Aluminium and sulfate present here. So we should know the formula like aluminium Al sulfate SO4. Okay, step 2, what we have first observed the radical. What is the radical over here? Radical is nothing but it's a charge and all the atoms combine to form only one charge. Combine to give only one charge. That is radical. Like aluminium sulfate is a radical. Radical is a combination of different elements all combined to give only one charge. Like sulfate is a radical of negative charge. Aluminium is an ion with a positive charge. Okay. So here aluminium is there, sulfate is there. Aluminium is there, sulfate is there. Now do valences have a positive or negative charges? Definitely. Yes. They are having, but when we are writing the valences, we won't mention it. When we do the crisscross methods, mostly we won't mention it, but there are charges. So how to write the charge? So for radicals, we need to by heart the valences for radicals. Like sulfate is having radical charges 2. So it's a negative charge, it's having -2, and aluminium is 3. How do we get the charges or valences? Valences of an element. I said that for radicals, we need to by heart the valences. And we should know the charge. So when this radical is present in any element, the charge and the valence is same. For example, radical is a combination. It's a sulfate. A group of elements to form radical, and it is having charge minus. Okay, aluminium is an ion, and it is having +3. It is having -2. This is radical. Charge, a group of elements connect charged elements. Okay. For example, I want to write aluminium. Just listen here. Aluminium. Atomic number of aluminium is 13. If I want to write the configuration 283. So to get 8, it requires 5 to 10. 5 to 10. It's very difficult to take 5. Okay, it is easy to take 3. So when it gives 3, what is the charge? AL plus 3. AL plus 3. Yes or no? Yes or no? To get 8, donates 3 plus 3. So aluminium plus 3, sulfate minus 2. Crisscross both the values. Crisscross both the values. Then what will be the formula? What will be the formula? Al to SO4. This is aluminium sulfate. SO4 is a radical, it is having fixed valency. It's having fixed valency. You have to by heart it. If you want, I'll provide you the chart to by heart the valences. Okay, next. One more example, sodium chloride. Sodium chloride. So sodium atomic number 11, 281. Chloride 17, 287. Okay. So to get 8, it donates 1. So to get 8, it accepts 1. So what will be the charge of sodium? Charge of sodium is plus, and normally it is donating 1. This is minus, it is taking 1. Intercross. So sodium 1, Cl1 with both opposite charges, so it has become neutral, and it is NaCl. The formula is NaCl.
MgCl2, I think.
Magnesium.
Mom, I think it's MgCl2.
You know, if you don't know, definitely you need to go with this. Am I right, Arya?
Yes,
What
ma'am.
you said is correct. What you said is correct.
Yes, ma'am.
Yes, very good. So, Mg, okay, children. So, valency means, valency is nothing but the combining capacity of the element. Here, how the elements are combining by donating the electrons and some are accepting the electrons. By giving and taking the different charges, the elements combine chemically. This forms ionic bonding. This type of bonding is nothing but ionic bonding. What do you mean by ionic bonding picture, ma'am? Ionic bonding means? Ionic bonding means? The bond formed in the ions, or by donating the charge or by accepting the electrons, the formation of bond. That bond is known as ionic bonding. So by this, these are nothing but ionic bonding. When we observe the charge, when we break or when we dissociate the molecule, definitely we'll be having the two charges of one with the metal and one with the non-metal. Two different charges are present, definitely it's an ionic bonding between them. It's a kind of bond between the two different elements by donating and accepting the electrons. Ions are radicals. What are the ions and radicals? Ions are the atoms containing a positive or the negative charge on which it bears a single unit. Single unit means one element with whether it is positive or negative. That is nothing but ion. What do you mean by radicals? A group of ions. A group of ions combine to form radicals. Understood? So a few more examples I can give for the radicals. Few more examples. SO4 minus 2. Okay. PO4 minus 2. CO3 minus 2. Let's see, all these are radicals, children. They'll be under one bracket or one this thing, one closed thing. These are radicals. It's CO3 minus 1. NH4 with a positive radical plus 1. Okay. Understood or not? So all these are the radicals. If you want, I'll give you the flow chart about it, and I'll give you the along with the concept or with the what I can say. I can send the PDF. Ask the crew and then send about the radicals, valences, and all. Radicals means a group of ions forms a radical. All the ions combined to give only one particular charge and one particular valency. Understood? Here, like sulfur is present, it won't have separate the charge and valency. All the radicals means a group of ions combined to give one single charge and one number of valence. Whether it is higher or the lower number, one charge will get. Understood? So let me show you about the valency. Valency electrons means the electrons which are present in the last shell. Valency means donating and accepting to form the capability of an element. Valency electrons means, for example, sodium 11, 281. This last electrons, how many electrons are present in the last shell?